The first question, the very simple question, I always start with the very basic question of this. One to the power 99 plus 2 to the power 99 plus 3 to the power 99 up to 100 to the power 99 is divisible by 10100. This you have to put. And you have not to tell this, just you have to say yes, sir. Done. You can write down in chat. Very good. Result, Saurabh. How many times you have done this question?
Sir, you have only made us do it once prior.
Hmm. तुषार तुषार आराम से होना चाहिए. You have done already. याद कर थोड़ा सा. We have done this question earlier. नहीं नहीं याद आया. May I start? 2 more minutes.
Yeah.
Aryan, switch on your camera, beta. Kone. Yes, Patyus. No. See. It's okay, everyone. May I start? See. This is the simplest, one of the simplest question. When I have to start my lecture and I have to teach the divisibilities and all, that's the first question, always will get the same one, right? So if you'll see this 10100, right? The co-primes of this is something like this. 101 and 100. Both are co-prime. Right. Means I have to prove that this is divisible by 101 as well as this is divisible by 100. If possibly I'm able to do both the things, one is for 101 and one is for 100. So 100% this will be divisible, right? So first I'm trying for 101. Since the power is odd, right, n is odd, right? So a plus b, right, a to the power n plus b to the power n will be always divisible by a plus. Is this okay? Is this okay? Right? So this will be divisible by a plus b. Everyone is okay with this? Or I have to prove this? I have to prove this or everyone is okay with this?
Okay, sir.
Okay, everyone, right? Now, so if okay, then I can say if I'll combine 1 to the power 99 plus 100 to the power 99, 2 to the power 99 plus 99 to the power 99, so on, up to 50 to the power 99 plus 51 to the power 99. So every pairs are giving me the factor 1 plus 100, 101, 2 plus 99, 101, and 50 plus 51, 101. So from this, I can say we have proved that this will be divisible by 101. Now, the secondly, I have to prove this, this must be divisible by 100. So now what I am doing, except 50 to the power 99 and 100 to the power 99, right? Except these two, I'm taking 1 to the power 99 plus 99 to the power 99, right? The again making this, right? So all these numbers will be divisible by 100, this all having factor 100. And these two always divisible by 100 because 50 to the power 99 is like at least 50, 99 zeros and 100 to the power 99, right? 198 zeros, right? So these all are divisible by 100. So 101 and 100 both are co-prime and the number is divisible by 101 as well as 100. So I can say this is divisible by 10100. I guess everyone is understanding this. It's a beautiful, beautiful representation of a question. The very basic concepts is given in different forms, right? Okay. Okay, everyone. Right. The second one. Prove that n to the power 7 minus n is divisible by 7. Take your time. Module congruency will not work in this. Right. Somewhat we can do, but yeah, without comma. Obviously without comma. Yes. Not bad, Aryan. Not bad.
Sir, I did it using modulo.
Hmm.
Sir, I did it using modulo.
Okay.
Same here.
Okay. Okay, everyone. Done. See, we know that numbers are in the form of, right, n is nothing but, right, 7k plus r, where r is equal to 1, 2, 3, 4, 5, 6, 7. I'm not taking because if the number is divisible by 7, so 100% this will be divisible by 7, right? So only I have to check with these numbers, right? 1, 2, 3, 4, 5, 6, and 7, right? If I'm writing this is in the form of 7k plus 1 to the power 7 minus 7k plus 1, right? So obviously I know okay, the unit place, right? The factor of this will be 1 only if I'm dividing this by 7, and this is 1 only, so this will be 0. So this is divisible by 7, first case. If I'm taking the second case, 7k plus 2 to the power 7 minus 7k plus 2. It is possible to prove this, this will be divided by 7. Yes, we can see this. This is 2 to the power 7, except the last term. Each and every terms are divisible by 7. So only the last term is not divisible by 7. So 2 to the power 7 minus 2 will be divisible by 7. 2 to the power 7 is
120.
7 divides 126.
right. So this is 128 minus 2 is 126. Right? So again divisible by 7, right? So for any other factor, we can see that this will be divisible, right? So 100% the number will be divisible. Check for 4.
Sir,
Yes, the 4 also it is divisible.
Yes, Anjana?
sir, we can apply Fermat's theorem, right?
Yes.
Where anything raised to p minus 1 divided by p will give the remainder as 1. So if we take out n out of the bracket, it'll be n into n raised to 6 minus 1. So n raised to 6 will give 1 as a remainder when divided by 7, and same for 1, which will give a minus 1. So when we subtract both of them, we'll get like 0, right? And then we multiply it with n again. We'll get remainder as 0.
Yeah.
So it's divisible.
Divisible. Yeah. Right? So Fermat theorem is also there, but I said key, like we'll study that Fermat theorem on thing, right? So what if I'm giving you n square plus 3n plus 5 is never divisible by 121. Right? That you have to prove.
So done.
Very good. Yes.
Saurabh, send the explanation in the chat.
Not understanding. Hmm. It's written that it's a multiple, right? It's not necessary 121, maybe 121 into 2, maybe 121 into 3, 4, 500, 2000 crores, anything.
I didn't mean multiple. I meant something divisible. I meant to say that it was divisible, so I took 121 as an example. Or we can even take 242 and 343.
This is not working. Maybe this will work for 121 into 3. Maybe this will work 121 into 7 or 100 or like some of the
Sir,
numbers.
then we can take it as 121n and then solve it.
But in that case, it's very difficult to say that for every number, this will be irrational. The roots are irrational. Huh? Getting my point?
Yes, sir. For 121n, then we can take any value, right? That's what I took.
Some other way you have to find for this, right? There's a beautiful arrangement of number, right? You'll learn a very good thing from this.
Sir, can we use contradiction?
You can, but how you have to create the contradiction, that's a perfect point you have to get from this, right?
सर
So
वो integer आएगा इसलिए उससे होगा.
take
Like
your
if we take
3 minutes, you have to contradict, then you have to be very careful. Other than that, no other cases are possible. Then only I can say this is the contradiction, right? So everyone take your time for 3-4 minutes, right? Right. This is beautiful question, right? Like all the exams, right, including IOQM or RMO, they have asked the question in that format. So please, now careful. And you have to remember this question, right? This question will be the reference. Many times this question will be a reference for you, right? Again, I'll tell you, like we have learned this, right, from that question. So again, apply. तन्मय,
सर अभी बस होने वाला लास्ट
Kavyam, Tanay, how are you?
Sir, nice.
All good na beta?
Yes, sir.
Hey, mm-hmm. Like, how could you predict that for every k this will be irrational roots?
Sir, I've taken a value k and then taken it into the left side. So n square plus 3n plus 5 minus 121k. So I took the general expression method in which I took a is equal to 1, b is equal to 3, and c is equal to 5 minus 121k. So after solving the equation, I'm still obtaining irrational roots.
We can't say if few values it's not coming to, you can't say कि always this will be irrational. Okay, let's start. Very good, very good. Kavyam, Hasma, please explain your point.
Sir, I took this number as 11k, so n square plus 3n plus 5 minus 11k is 0, and its discriminant is coming as 121k minus 11. So discriminant is divisible by 11, so n cannot be divisible by 11.
So, but we don't know for sure if it's 11k. So I took 11k plus r and then I substituted that value of n in the equation. And then I got everything is divisible by 11, which is very obvious, except r square plus 5. And r square for r, we can have values from 1 to 10. So by hit and trial for r square plus 5 from values of r from 1 to 10, none of the values are divisible by 11, so we can tell that the whole equation is not divisible by 121.
Not bad, not bad, not bad.
Sir, this is another proof that it cannot.
You can't say it from this. See, what I mean to say from this. N square plus 3n plus 5. What you have to try, this is divisible by 11, right? Or 121, right? This I have to prove if this is divisible by 121, right? So what I'm doing, first I'm trying if this will be divisible by 11, right? Then I have to take out the 11 square because 121 is nothing but 11 square. So first I'm trying to somehow I'm able to manage this for 11, right? Is this okay, everyone? Right? So the nearest thing I can see from this is n square minus 7n plus 4n, right? Plus or minus 28 plus 28 plus 5. Is this okay? So this factorization serving two things. What is that? One, this having the factor of 11 and this having the difference of 11. And this is having factor of 11. Right? One having difference 11 and other having factor 11. Right? And now I have to think on this. Right? See, this having difference 11 and this having factor 11, right? So if I'm taking any number, right? So any number, right? N plus 4 minus n minus 7 will be 11, right? This is always divided by 11. Are you understanding this part? Is this okay, everyone?
Yes.
Right? This will be always, and this is again divided by 11. Right. So 11 will be the factor of this, right? If I'm taking 11 as a factor of this, means n you are taking as n is equal to 11k plus any of the number 1, 2, 3, 4, right? And 11k plus r, right? So these two numbers are showing 11k plus r minus 7 and 11k plus r plus 4, right? Plus 33. So from this, I can say r minus 4, r minus 11. I'm taking any of the number r is equal to 1, 2, 3, or r is equal to 7. So r is equal to 7. So this will be r is equal to 7. This will be 11 is a factor from this, right? So always I'll get 11 as a factor of this and 11, 11 coming up. So this having 121 factor coming from this one. Is this okay, everyone? And this is happening why? Because we are able to write it down in the form of this. Right? We are writing this number n square plus 3n minus plus 5 as n minus 7 into n plus 4. Right? That's the reason we are able to write it down in this form. So I'm writing this as n minus 7 into n plus 4. Right? So the difference of these two are 11, right? So anyhow, when you are taking any of the number, right, n is equal to 11k plus r, right? I hope everyone is understanding this. Again, I'm coming into this. 11k plus r minus 7, and this is 11k plus r plus 4. Right? If I have to take 11 as a common, so I know that maybe r is any of the number 4 or 7, right? Something like this, minus 4 or 7. If I'm taking 7, so this is 11k, and this having 11k plus 11. Is this okay? So overall, that I'm saying 11 square is common out. This is k into k plus 1, right? So once it's possible, right? Possible that 11 square is coming from this number. If 11 square is coming from this number, means this number, right? This number is divisible by 121. And this number is divisible by 121, but from this, I'm getting only the factor of 11. What is the meaning of this?
That means that n minus 7 into n plus 4 divisible by 121, and when we add 33 to it, can never be divisible by 121, but may be divisible by 11.
Very good. Means overall, only the factor of 11 I can take out from this. Right? It's not possible to take out the factor of 121 from this. And other than 4 and 7, if you will take any of the numbers, so this will be not divisible by 11. So that's the reason we can say, okay, we have tried this by the factorization also, but we are not getting the number that is divisible by 121. Is this okay? Is this okay, everyone? Please write down yes if you understand. Very good. Very good. So you have to take out the factor when you require divisible by 13. So we have to take out the factor as n, right? N plus 4 and minus 9 or something like that. You will get a difference of 30, right? And directly this question was given in R1. Directly this question was given in R1. Directly. Okay. Done, everyone? Okay, everyone. Done. नोट कर लिया सबने? संजना, डन बेटा?
Yes, sir.
Okay. Raj? Okay.
Yes,
So
sir.
can you scroll up?
Just a minute. Yeah.
So done.
So done.
Okay. So this is the concept when you have to take out any of the squares, right? The square of the number 11 square, 13 square or something. IMO given the same question with the 13 square. Right. And once again, they have given the question with 17 square. Right. So remember this format, right? So you'll be able to catch out the things exactly. Okay. In next lecture, we are going to do with the base work, right? We always doing the numbers with the base 10, but most of the time, the RMO question or IOQM questions, right? And INMO again, right? You'll get a question when bases are not 10, right? Base are 8, 15, 16 or something like that. And then we have to change the numbers accordingly. And the like different types of questions are possible. So you have to remember, again, we have to do that, right? One very simple question I'm going to give you and expecting everyone will answer this, right? Is 5522222 to the power 5555 and 5555 to the power 2222. When divided by 7, leaves the remainder. When divided by 7, leaves the remainder. You have to find out the remainder when you are dividing this number by 7.
Another huge number problem.
वही तो इसी टाइप का था ना, an plus bn is
Done, Pratyush?
So done.
Yes, sir. Very good, Kavyam. Receive done.
So 1 minute.
So done.
Very good. Write down the answer, please, everyone. Write down the answer. Okay, let's see. So one of the method is, right, 2, 2, 2, 2. When dividing by 7, what is the remainder you are getting?
3.
Huh?
3.
3. So this is coming as 3 to the power 5,555. Right. And what remainder you are getting from this? 4.
4.
4 to the power 2,222. Right. So we know that when I have to divide by 7, so we know that this 3, so 3 cube is
-1.
1 raised to -1. Right. And I have to get 5,555 powers. Right. Nearest to this will be
So then we would get 5,555. We could do like 3 to the power 5 and then
power 1851 into 3 square into 3 square, right? So getting -1 into 9 is equivalent to -2 or 5, right? Is this okay for first one? We are getting -2, right? For the second one, when we are taking 4 to the power 2,222 divided by 7. So 4 cube is 60, right? 4, that's 63 plus 1 divided by 7. So this 4 cube is coming to be 1 mod 7, right? And this
4 to the power 222 equals
4 to the power, right, 3,
222.
7
4.
into 4 square, right? 16. This is coming as 2. So this is coming as -2, this is coming as 2. So remainder will be 0. Is this okay? Right? Everyone is getting the simple question, but you can also do this by some adding or subtraction. That we have to think of what we have to add and subtract, right? So later on, right? So find unit digit of 9 to the power 9 to the power 9. Right? It's a simple question. Then we'll go for the 10 digit, right? But obviously, first we have to start with the unit. 9 to the power 9 to the power 9. It's the simplest one. So please do it fast.
Third,
Very good. Right? So we know that the power of 9, right? Power of 9, if the power is odd, right? Power is odd, then it will end it with 9. If power is even, it will end it with 1. That's it. So this having the power odd, so 100% this will be ended with, right? But the main question arise when I'm asking 2 to the power 999. Find last 2 digit of this number. 2 to the power 999. Find the last 2 digit of this number. You can see it like the change of this, right? Initially, this was very simple. Now this is going in the different direction, right? So you have 4-minute time, right? Take your time. Just we'll discuss accordingly. Sanjana, the question is you have to find last 2 digit of this number, 2 to the power 999, right? 100 place and 10. You have 4-minute time. No purchase. Again, go for that.
sir, is my answer correct?
So it's last 2 digits, right?
Yes, last 2 digit. No. Aryan. Try.
So now is my answer correct? Sir, is my answer correct? I said that.
Yes, Aryan. No problem. So, yeah.
Just
Start.
one, just one more minute, sir.
Okay, okay. Very good, Sivan. Use थोड़ा सा और बेटा. Aryan, very good. You have to explain this question, na?
Yes, sir.
So be ready with that. Last 2 minutes, everyone. Not bad, Sanjana. A little bit, I guess. The digits are here and there. But I guess you are going in the right direction. Okay, let's start.
So 1 second.
Very good, Satyus. Very good. Kavyam, very good. Very good. Now everyone is getting this. Very good. Yes, very good. Tushar, a little bit better, but not bad. So let's start. So I am, as I said, please go.
Yes, sir. So, sir, what I did is that I have taken mod 100 from 2 to the power 1, then I continuously multiplied 2 until I got a definite pattern. Then after that, I took it as 1, 2, 3, 4, 5 remainder. What remainder will come of 999, and then I divided it by, so I got it as, wait, 1, 2. Sir, I got it as a definite number of numbers in which the series will come. After some time, I got 4, 8, 16, 32. Then after that, I get 52 and 4, then repeats again, and then we again get a cycle.
Just
So,
multiplying again and again and again.
Yes,
You are
sir.
not bad, not bad. Yes. Anyone else? Right. You can say like 2 to the power 10 is what is the number when 2 to the power 10 is there. right? Then you have to multiply with 10, then you have to multiply with 2 to the power 10 again, then 2 to the power 1, and then 2 to the power 9. So what number you are getting will be the number. This is 111, 111 into 9. Nahi? So, Pratyush, what you did, beta?
Sir, same as INMO found the pattern.
So everyone is same or little bit different?
Yes, sir, the
So
same.
1 minute trying a different method.
Different thing. Well, I'm going to explain the different theory, right? This is one of the theory what I have said here, right? Just you have to take out the numbers, just multiplying, you're getting the number, right? Right. I'll go with one more method, right? This is one of the method where you have to just go with the repeating the numbers again and again, right? Right, and just see the calculation. This is the like basic method. I think you can go through that. तन्मय एक बार चेक कर बेटा.
सर मैंने भी वैसे ही किया पर सर उसके बाद मैंने बस थोड़ा सा अलग किया. सर आई 999 और 2486 के पैटर्न में टू टू आता है तो फिर उनका इसका यूनिट डिजिट 8 होगा और 2 to the power 7 120 और 2 to the power 6 128 होता है और उसके बाद और 2 to the power
6 is
नहीं सॉरी 2 to the power 7 is 28 के लास्ट में और 2 to the power उसके बाद 11 2048 आता है तो फिर 4 के पैटर्न में लास्ट में पहले वाले में 2 उसके बाद 4 फिर 6 फिर 8 तो वैसा वैसा पैटर्न 999 तक फॉलो करता है तो सर बस अभी थोड़ा एपी से
okay, not bad. Okay, is it done?
So 1 minute I think मिल गया मुझे थोड़ा different method.
Okay, good. Let's see. Is it next?
Just a minute वो मुझे मिल गया almost. थोड़ा सा और calculation.
Tushar, got the answer?
नहीं सर। सर मैंने भी पैटर्न से ही किया था।
कैलकुलेशन कुछ फंस रहा है, नॉट गेटिंग द कैलकुलेशन.
सर आपके मेथड से 88 आया, मॉड से।
See, very good. So what I'm saying, we have to find 299 and closest to this is a number is 2 to the power 1000, right? So what we have to do when this will be divided by, right? ये वाला number को 100 से divide करो या ये वाले number को 100 से divide करो, what I'm getting, just we have to see. So just I'm starting with, we know that 2 to the power 10 is nothing but 1024, right? 2 to the power, right, 10 is 1024 and 2 to the power 10 plus 1 is 1025, means this is divisible by 25. Is this okay? This will be divided by 25, right? So 2 to the power 20 minus 1 will be divided by 25. Is this okay? So if I'm saying 2 to the power 1000, right, minus 1, so this is again divided by 25. Because we can rewrite this as 2 to the power 20 or 50 minus 1. So once it will be, right, a factor will be 2 to the power 20 minus 1 or 2 to the power 10 plus 1, right? So this will be always divided by 25. Is this okay? Right? Any problem in this? यहाँ तक मैं पहले एक बार चेक करो, कुछ प्रॉब्लम, कोई नया बात मैंने नहीं करा, जो पैटर्न आ रहे थे मैंने पैटर्न लिख दिया, राइट? कहानी खत्म हो चुकी है, इसके बाद मैं आंसर पर आना शुरू कर जाऊंगा, राइट? सो जस्ट यू हैव टू सी दिस द पैटर्न. Is this okay, everyone? Right? Means I'm saying if I'm dividing 2 to the power 1000, that be equivalent to 01 mod 25, or this will be 26 mod 25, or this will be 51 mod 25, or this will be 76 mod 25. Right? These 4 options are there, right? When I'm saying, when I'm dividing 2 to the power 1000, right, 25, and I'm getting like minus 1 is divided by 25. So this is saying that it may be like exactly divided by 25, then I'm getting the number 01. And if not the factor of 25, so 50 or 25 factor is there. So like the last 2 places I'm getting double 0, or maybe I'm getting 26, right? Then I'm dividing by 25, then 25 plus 1, maybe I'm getting 50, right? After dividing to 50 plus 1 or 75, so 75 plus 1, 76, right? Okay, everyone. But we know that this number 2 to the power 1000 is divisible by 4. So the only possibility with 4 number is 76. Right? Means अब मेरे को क्या चाहिए, 2 to the power 999 we required, but we have found for 2 to the power 1000. We required for 2 to the power 999, right? So 76 is divisible by 2, right? So 76 I'm dividing by 2. So first case, maybe I'm finding 38, or maybe I'm borrowing 1 and dividing this, so I'm getting 88. But this number is not divisible by 4, but this is divisible by 4, and this number must be divisible by 4. So the last 2 digits of the number is 88. See this carefully. So we have to make a plan for this. Maybe, right, with few steps, right, we'll be able to get the numbers. I hope everyone is understanding this. This is the like same question with different approach. You know that approach, right? When you have to just find out the numbers and multiplying this. Or just we have to think if one of the cases there where we will be able to get out.
सर मेरे को इसी का थोड़ा एक अलग तरीके से है सर इसमें मैंने पहले 2 to the power 1000 लिया और उसको आई रोट एज 24 to the power 1000 क्योंकि दोनों में फिर लास्ट 2 digits सेम ही आए एंड देन
24 to the power 1000.
हाँ सर सॉरी 24 to the power 100 मतलब 2 to the power 10 to the power 100 हाँ 24 to the power 100 माना उसको and then 24 square I'm getting 576 मतलब -24 mod 100
Very
so
good.
24 to
This
the
is
power
the same approach that you use. Understand, this is the same approach what you have done. Just you have used the binomial instead of we are doing the modulus concurrency. Right? Just 1024 is same as 1025 minus 1. Now you have used the binomial for that. We are using not the binomial, we are using the congruence one. Right? Okay. Okay, everyone. Right, one question, right, the out of context, one question I'm finding in this book, in the same chapter, I'm finding, right, a very basic question. Just I have to check. You all have done this question before. Just you have to tell me, yes, sir, and how that you have to like prove in that way. Prove that if the coefficient of quadratic equations are odd integers, ABC belongs to odd integers, right? Then roots of the equation cannot be rational. Rational. Roots of the integers cannot be rational. I'll send you the question by tick mark, right? Or I'll write down the number. Just you have to complete those questions from the book, right? I'm sending you the photo of this, right? And if you have time, right, then you can go and solve each and every question. I'll discuss those questions. Or if you don't have time, right, go for like those questions, what we have, like, I'll just tick mark the question or something else, right? Write down the numbers. Okay, Sanjana.
Yes, sir.
Understand now that one, the second approach of that question.
Yes, sir.
Kavyam, very good. Maybe you will be able to solve in like 1 or 2 lines, not more than that. Kavyam, try once again, beta. Very few question I have given, na? Yeah, that.
Just 1 second.
Okay. How you are using beta theorem? A complete solving or
So using Vieta, the product and sum will be like odd.
Yes, so we can do it by Vieta.
how, like how you are going through that?
So by Vieta, we get product of roots is equals to C by A.
Mhm.
Since C and A both are odd, alpha and beta, taking alpha and beta as the roots, they will also have to be odd. But then sum of roots is equals to minus B by A. And if you add two odd numbers, you get an even number, but B upon A is odd. So it's not possible.
Okay, you are saying ki alpha into beta is equal to C by A. Alpha plus beta is equal to minus B by A, right?
Yes.
So it's saying that A and C are, this is the fraction, right? So alpha, beta may be rational numbers. So fraction is coming up now. So alpha, beta is not integer. I'm saying ki, right, A, B, C are odd integer, then roots of alpha and beta integer cannot be rational, right? So alpha and beta are rational number, maybe 1 by 2 or something, right? 2 by 7 or something numbers are there. So right, two odd number, the rational number we have to add. So difficult to say, I guess. Right? Yes, Kavya? Utkarsh?
So we can use that b square minus 4ac.
Very good.
So and then like you can use contradiction to prove that like so the result 4ac should be odd, sorry, even, but I think so after simplification. So one I will just send the whole solution.
See, we are assuming
Sir, I
that.
have done with that method.
Yes, Raj, please.
Sir, in this I have इसमें क्या किया कि हमारा हाँ yes we have taken the quadratic formula inside the root b square minus 4ac should be a square. तो हम लोगों ने ऐसे ले लिया, फिर हम लोग 4ac equals to b square minus I square लिख सकते हैं.
We
So
can write
b minus
I square is equal to 4ac, right? Since b is
then we
odd
can factorize them.
and this b is odd and 4ac is
Yeah.
even, then 100% I must be odd. Is this okay? Is this okay,
Yes, sir.
everyone? And we know that difference of a square of two odd number is divisible by 8, right? But the right side is divisible by 4.
Only 4 and a and c are odd.
So this is not possible. But what I was saying, it is given ax square plus bx plus c is equal to 0. Let the roots are p by q, the rational, right? We are assuming the roots are rational, so it must be in this form, and this is let p by q. So this will be a p square plus b p q plus c q square is equal to 0, right? And we know that p and q are co-prime. So if p is odd, right, so q must be odd, one of the case. Or second case, if p is odd, q must be even, right? And ABC are odd, right? So if p odd and q odd, right? This is odd, odd into odd will be odd number. This is odd, this is odd, right? Sum of three odd number is equal to 0. Sum of three odd number is equal to 0. Is this possible? Is this possible?
No,
Right?
sir.
No. Means no solution for this.
Because if we
Maybe-
take 2, then 2 will become even and third must be even, else it is not possible.
Very good. And second case, if I'm saying P is odd, Q is even. If Q is even, so this will be even, this will be even, right?
Which
And
cannot
one
be
of this is odd. So
yes.
is this possible that this number will be 0?
Yes, sir, it is possible when one is even, but it does not satisfy our conditions that all the questions are odd.
Look, first number is odd and second and third are even. So 100% we can say this must not be
Will
equal
never be
to
zero.
0. So both the cases, I have not to solve this. Why to solve this? The basic even and odd question. This is the parity. This is the parity. Understand?
Yes, sir.
Like a lot many methods are there. I'm not saying only these methods. Let's see. See, you can see this, right? I'm saying, like I'm solving this, right? So I'm saying let ax squared plus bx plus c is equal to 0. And I'm assuming b square minus 4ac as I square, right? Since b is integer, ac and 4 integer, so b square minus 4ac must be integer. So b square minus r square is equal to 4ac. This is b minus I into b plus I is equal to 4ac. I'm assuming b minus I, since b is odd, I is odd, so this will be 2m. B plus I, b is odd, I is odd, so this is 2n, right? So I can put this 4mn is equal to 4ac. 4 cancel out, so mn is equal to ac. If I'll add both the terms, right, this one, so what I'm getting from this two, b is equal to m plus n. 2 cancel out, b is equal to m plus 1. Since b is an odd number, so this is possible only if one of this mn must be even, other must be odd. So m is even, n is odd. So this must be even number. But this is given, this is odd. Means this is not possible. So 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 root must not be integer. Not many methods are there, right?
Sir, can we write b square as 4m plus 1 and then
Very
solve?
good. 4m plus 1.
So because b is odd, so b square can be written as 4m plus 1.
Why 4m plus 1? Why not 2m plus 1? Because in those cases, like you are excluding some of the values, right?
Yes.
Maybe for those cases, it will be true.
Yes.
So that could be wrong, right? I hope you understand, right? So I have sent you this right questions. Please, very few questions I have given you, right? Please solve all the questions. We will discuss in next lecture, right? Thank you, everyone. Enjoy your Eid today.
Thank you, sir. Bye, sir.
Thank you, sir. Bye, sir.
Thank you so much.
Eid, everyone. Bye
Bye,
bye.
sir. Thank you, sir.
Thank you so much.
Thank you.